Okay, so what else with images? We now have lazy load. So with lazy load, we can apply loading equals lazy to some images. What's the idea? The idea is to lazy load images that are not in the viewport, so are not currently visible. They are not in the pub default. When you start scrolling and those images are becoming to be in the viewport, not exactly, it's not waiting for for them to be in the viewport. It's when it feels like you will see more images, it then goes and loads those images there. This has pros and cons because yeah, when you scroll, you may see some white spaces because the image is not there yet. But also what it's doing is clearing up the bandwidth for the initial load. So we're not downloading everything. So for example, in our case, we do have this images that typically can be there. Before HTML supporting this, we were typically using JavaScript libraries, some external dependencies that were looking at the scroll event and verifying the position of images and loading this with lazy load. Well, now it's pretty simple. It's just loading lazy. So we can go to our code, script.js, and add to the images loading lazy. So if the image is in the viewport when the page loads, it won't change a thing. If it's below, it won't download the image until it's close to appear on the screen. Which again, will probably, not everyone is scrolling your websites. It depends on the website, but sometimes it's even less than 20%. And why are you downloading resources that 80% of your users won't see? Well, that will also like leave your server a little bit more space to do other stuff, so it helps a lot. Should we use loading lazy with everything? No, not really. Definitely not for LCP images. Definitely not. So for our LCP image that now is embedded in the HTML, talking about this one, don't use lazy load. We want it because a lazy load also changes the priority to low. And no, we want high priority, okay, on that one. Remember, don't mess with your LCP image. Also, something to play with, it's async image decoding. So this is something that we don't have enough research yet to have a final conclusion on when it's a good idea to change that or not. But decoding the image is actually a process that is being done in the main thread. It's not the biggest of the deals in page loading. Okay, this is taking the bytes of a JPEG and actually getting a bitmap on the screen. That's decoding the image. You can actually say sync or async. When the image is really important, you want sync. Because, okay, you need to stop everything and go and decode that image as soon as possible. I want you to do that when you have time. No. So decoding sync, we have a candidate for decoding sync, our LCP image. Does it make sense? Decoding sync. Because this is the most important image for our web vitals. And remember, it's not because of the sake of performance, of the sake of having good web vitals. It's because that will improve users' perception and that will increase business opportunities and conversion for our websites. That's why we're doing this. Okay? So web fonts. Someone asked about web fonts here. I have more info on that. We need to avoid FOUT, flash of unstyled text. Remember I mentioned that text by default is non-blocking, and when we add web fonts, we are converting that into blocking. Well, something that we can do is to use font display optional or font display swap. And in this case, every browser might change the implementation of this, but we are saying, hey, let's start with swap. If you say font display swap, the browser will first, it will wait. It will start downloading the font. You have a title with a nice font. It will download the font, but it will wait like 200 milliseconds, around that. If within 200 milliseconds it cannot get the web font yet, it will render the text with the next font in the list. Font family has a list, a comma-separated list of fonts. And when the font appears, it will swap the font. So you will see kind of a flash. I mean, it's Times New Roman and then it's a fancy font. Optional, it says, you know what, if you can't load the font, it's okay. Go ahead with the next one. In this case, typically the browsers are waiting a little more. It can wait like 100 milliseconds. If the web font is not ready at that point, they say, okay, we give up. Let's move to the next font. And it will render the text immediately with the next font. You won't see a flash, and you won't see a text for some milliseconds, but not forever. Make sense? In the case of, let's go to our example. In the case of web fonts, today, well, I think this is the one I pasted from Google. You can add that property in the URL, such as in this case, display swap. In this case, we are asking Google to add font display swap. But if you don't want swap and you want optional, you can say optional here. And in our case, it will use the next font in the list. So if Inter is not within 1 second, it will go to sans serif, or I can add Arial, wherever. Make sense? With that, you will avoid that flash of an style text that sometimes you get into a website, you see buttons, you see a logo, and nothing else. You see why we have white around, because the font is still loading. The text is there. The browser is ready to render the text, but it doesn't have the font. Okay? There are more things to do about fonts. Now we have an API, so you can check if the font is installed. If it's installed, you can use the installed version of the font instead of downloading. So if you want to get more into web fonts, there's much more to read about that. HTTP client hints. The idea is for external resources. We are talking about resource loading. What if the server can receive data about the client to make better decisions about the resource that it's going to send you? For example, images. What if the server knows the pixel density or the resolution of the current device? So if you're asking me for an image, I know if you are on a laptop computer, if you're on a laptop with a retina screen, so with more resolution, if you're on an iPhone, if you're on an Android, and based on that, without the client making, without using the picture elements, so the server will make a decision. And for that, we can expose data to the server with a spec known as HTTP client hints. It's a meta tag that you can define in the header of your HTML that actually, more than a meta tag, is an HTTP header that you can also express as a meta tag. That's better. Accept CH client hints. And in the content, you set a comma-separated list of properties that you want. Okay? Give me a second. We can ask today for RTT, round trip time. So that's the latency. We can send to the server the current estimated latency that we are having. So the server can decide what to return. Downlink, that's an estimation of the bandwidth. So again, if the latency is 400 milliseconds, something's wrong with our connection. So the server can say, well, let's return something simpler. Let's do something about, let's increase the experience for that user. Does it make sense? This is the effective connection type, ACT, effective connection type. It will give you a string if you are in 2G, 3G, 4G, slow 2G, and that's all. So there is no 5G or Wi-Fi. In those cases, they will give you 4G, like the best one. Save data. That's a Boolean value that will give you the hint that the user wants to save data. What does it mean for you? It's your problem. So you can return images in low resolution if you want to honor that settings. Where is the settings? I will show you where it is, but on Android, on Chrome, for example, you have a settings save data in the menu. On iOS, you need to enable that in your current connection settings in the Wi-Fi or in your data connection plan that you have with your carrier. You can enable save data. DPR, that's device pixel ratio. That's the resolution, the pixel density. View per width, that's the actual width in CSS pixels. And device memory, how much memory the device has. So you can request the client, the browser, to send that data to every resource HTTP request. That's an HTTP client hint. Does it make sense? If you have a lot of work server side to do something with the information and with a hint. But the idea is to increase the user experience. By the way, the memory is expressed in MIB, that we know that it's not Men in Black, okay? It's megabytes. So, so now you will see that many times. That, by the way, that's so the idea that we have kilobytes and kibibytes. It's the only thing that I know that you will remember from today's course. That's the only thing you will remember. So let's say that your website is already loaded. You're OK with it. Now we will see in our example if there is anything else we can improve. What about to hack the interaction experience? Well, first, a big warning, we shouldn't do client-side rendering. I'm sorry. I know it hurts, okay? But client-side rendering for the initial load, for the content that you see initially, it's a very bad idea. It's a terrible idea for performance. And again, yeah, but we know we like React because blah, 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 blah. I don't care, we're losing money. So it's not enough reason. Whatever reason you are thinking, it's not enough reason if we are losing money. If you are paying for ads, if my company is paying for ads for a website that then users are not using because it's slow. And if you don't believe me, because I know that a lot of you will not, you are not really convinced that this is true, that a couple of milliseconds will make a difference. There are a lot of research on that, but do a research on your own website. So do some A/B testing. In fact, Amazon did that, and they released the research. That was a long time ago. They were creating experiments with groups. So let's say in the next hour, we split all the Amazon visitors in 10 groups. Group A, we won't give them any delay. Group B, we add 50 milliseconds delay, 100 milliseconds, 150, and then we analyze conversion. If you are large as Amazon, you will see a lot of traffic, and in 1 hour, you can get enough details to have conclusions, and you will see, okay, what's the difference when you have delays and when you don't have delays for the same UI. And on the Amazon research, like a decade ago, they realized that they were losing 1% of sales, 1% of sales every 100 milliseconds of delay. That's a lot. It's a lot of money. That might be different for your case. That might be not the case today. It was 10 years ago. Maybe it's different. But anyway, it has been proven that always better performance leads to better conversion. How much? It depends on the case. And again, you can measure that. You can do an experiment. And that's why client-side render is a bad idea. And that's why even the React team, if you go today to the React documentation that was updated a few weeks ago, now they don't suggest client-side rendering. It's still there as one option, but it's not the recommended way to do React. The React team is recommended to do React with a framework, such as Next.js. The framework that is server-side rendered. Or it's a mix. It starts as a server-side render, and then it moves to the client, which is fair, and that's because of performance. Because now we know that pure client-side rendering has performance issues, and pretty bad performance issues. Okay, does it make sense? So also, if you really have heavy tasks, you're going to start thinking about moving that to WebAssembly. So if you're you have a really long task, and creating a thread is not making that better, because you can create web workers as well with JavaScript. Another way is to create a module in WebAssembly. Now it's compatible with every browser. Scoosh, the app that we saw that is converting the apps, is making all the conversion in WebAssembly. So it's an option. It's there for us. I know that as web developers, it feels really strange. Like, some strange guy there that we don't want to see, we don't want to touch, but it's something interesting, okay, to see. We are not going to write dumb code in WebAssembly, but for a lot of processing, it might work. Yeah.
Can you give me a real-life example of something you would use WebAssembly for?
Well, Scoosh is one example. In that case, so processing bytes, binary data, in this case, converting JPEGs into WebP files, that's a good example. Today, decoding, encoding, things like Amazon Prime, video, Netflix, Star Plus, Paramount Plus, they're all using WebAssembly for decoding and encoding video. Typically, it's about processing data. Of course, then we have, talking about legacy, we have some interesting things going on the web. You can run any legacy DOS application, for example. Or you can run Windows on top of a browser or Quake 3. And there are a lot of examples like that. And they're using WebAssembly. They're just taking some code written in C 20 years ago, 30 years ago, and they're converting that into a WebAssembly module and running it in the browser. So yeah, those are very niche ideas for a web app. But my thing is that if you are parsing a lot of content, making a lot of calculations, and you see in the console or using APIs that I will mention in a minute, that it's a long task, so it's taking too much time to execute, then you might be thinking, well, maybe we should start thinking about WebAssembly.
And I'll just add that we have a course by Jem Young on WebAssembly as well.
There you have it. Front-end master for everything. You know that. You shouldn't be watching Netflix at all. Everything should be here at Front-end Masters. Okay, so stop serving legacy code. What is that? That is, unless you really have a need for that, like you are serving some customers that are still on IE for some reason, you shouldn't export ES5 content anymore from, if you're using a framework or library, you can change the setting. It's safe to move to ES6 today. That will ship less JavaScript, and we know that JavaScript is really harming performance. If you still need to serve some old users, maybe it's better to have 2 versions or something like that, because we don't want to have performance just for 0.1% of your users that might have a problem, and you are having performance for 99.9. It doesn't make any sense. Let me get some water. Reactive web performance is kind of an intro for the next and final part of the workshop. It's an idea. What if you can know about the context with APIs? What's the context? The performance context, such as how's the latency, how's the bandwidth, how's the CPU and GPU, and you can make decisions about that. So using different APIs. Network Information API is a JavaScript API that will let you know the current, for example, latency. Performance observers. Save data, that's client hint that I mentioned before. If the user wants to save data. Device memory, and more. And then, based on that, you provide a consistent experience. I mentioned Netflix and other video-based apps in the past 10 minutes, and we can take them as examples. So think about this. When you're watching a TV show or a movie on Netflix, do you see buffering a lot, like a loading spinner? Maybe the first second, but then while you're watching, you get a consistent experience, even if you're having network issues. I'm not sure if you have seen that in action, but maybe you're watching a 4K video, and at one point it lowers down the quality. And maybe it's very pixelated at one point, and then it comes back to 4K. So it's not, that's actually providing a consistent experience. So it's not like breaking the flow of watching or having that experience, it's just changing the quality. But if we can think for some web apps, something similar. So, and enable or disable web fonts, change the service workers cache policy to be more local or be more remote. like cloud-based. Remember service worker that can serve locally? Well, maybe we can serve locally only if the latency is too high. And if the latency is pretty good, well, maybe let's go to the cloud and be more updated. Decide between server-side render or client-side render. Maybe you say, you know what, I can't change this. Maybe you say, I can't change this, but if the user is in a mobile phone that is a low level, low memory, maybe let's jump to server-side render. Because it's going to be really painful for the user to execute our 3 megabytes React application client side. Reduce the amount of data that we are loading by default, and even delivering a 1x image that is an image without high resolution, standard resolution image, not matter the device pixel radio. Because maybe you are in an iPhone 17 Pro Ultra Max, but you are in the middle of nowhere with 2G. So it's not about the phone. The context is more than the phone, the device, and the screen size. In this case, the context is about the latency, the bandwidth, if you're in roaming and paying for the data or not. So maybe you can change the experience. Okay, make sense? So you can define based on different situations, what are you going to send to that user. Google is using this a lot because Google needs to serve users everywhere. Okay, that's one provider doing that. And even you can even set different budgets based on the context you set. So you say, okay, if we are in this context, we set a budget of 170K total for all the JavaScript, all the CSS. If you're in Wi-Fi on desktop, we have more budget, so let's use it. Of course, this has a lot of work behind, because you need to think about how you're going to do that, how you're going to create that structure, okay? But it's possible. I'm saying that it's possible. Also today, you can get reports from the browser. I'm not sure if you know this. So you can get real user metrics from JavaScript. There is, for example, the reporting API. With the reporting API, when you are serving the user the HTML, you can add a header. It's called report to, and that header will have a server endpoint. Then the browser in user's device will send you information every once in a while about what's going on with performance and other problems for that particular user, and you will receive that information at your endpoint. Okay, make sense?
Is there any kind of permission problem with that? Or?
It's first domain only, so it should work on the same origin. So it's your own website, just giving the browser an endpoint. So you don't need a permission, and it's on a best effort scenario. So it's not guaranteed that you will receive all the data, but you will receive some, and then you can gather analytics and do something with it. Okay? And that leads to the last section that I have for you, that is using performance APIs. But before doing that, let's go back to our example, and let's see how we are doing right now with performance. Is it better or worse? Let's go to Lighthouse and grab, remember 60 was our last score. Let's see what happens now. I'm still having my let's say bad server that I can solve as well, because that's a problem that I have. You can see I'm still at 60. So why is that? First, I can try this several times. The problem is that we have a lot of speed index. Remember speed index? Remember the average of the budget is 2.5, and yeah, 7 is actually far away. And largest contentful paint is better than before. It was 7, now it's 5. It's better, but we are still having problems because time to first byte is really high. What is time to first byte? The time that it takes for the first byte from the server to appear, and that is just because I was adding that delay. Okay, if I remove that delay. But the delay was actually necessary for us to see things better in action. Okay? If it's local, if it's too fast, it's difficult to actually analyze this. So now that I don't have that delay, I'm going to start create a new page load. Do I have the server running? Let's see. Let's stop it right again, just in case. There we are. Okay. Is it dead? Let's see. Let me open another tab. Let's see. I don't know if it's the browser or service running. Everything is running. Let's see what's going on. See if we can do this without making a break. Chrome, restart Chrome. Are you ready? Oh, I know what's going on. It was me.
When you commented out the timeout, the callback got commented out.
Now, the problem is that if I have a middleware, I need to call the next middleware. So actually what I need to do is this. So I will do this part again. So I just commented the set timeout, but what I need is to commit the whole middleware declaration. If not, this is how Express middlewares work. I'm not calling the next middleware that is the one that is serving the files. Okay, so I will do that again. So what I want is to, but let me first, yeah, it's okay. What I want is to remove my middleware so we don't have that fake delay, and now it's a more normal server. And now it's almost instant. Of course that, yeah, it's still local, okay, we know that. But we can try to get the results from here. And now we are at 94. There's still place for improvement, as you can see here. Largest content frame is still 3.0 seconds. We need to find why. And here we have examples. Well, I'm not converting all the files into WebP and AVIF, so that's why it says, hey, you should maybe, okay? Because I did that only with the first one. Oops. Also, there are some render blocking resources here going on. That's CSS and background CSS. That means a blocking resource is part of what is known as it's the path. It's the critical path. Okay? The critical path is all the files that are necessary to render something on the screen. So without those files, the browser will never render. For example, here, maybe it's a good idea to merge styles and background into one file. In HTTP2, it's not going to be like a big difference, but it says, hey, be careful because those are blocking resources. Okay? Then, and this is true, our CLS isn't really good because I'm not setting the width and height of those images in the HTML. So you should add width and height, so that will create CLS, layout shift. Okay, here you can see the critical path in action. Of course, this tool is much better with large websites, where you can sometimes it's not so simple to see it. Okay, but anyway, we are pretty good now. We applied a lot of techniques mostly for getting a better web vitals. There is still room for improvement, and on every website, remember that you need to test and see which things are better for you. So don't trust me, don't trust the slides, don't trust the book, trust your own testing. Okay, that's kind of what you need to understand. Do you have a question or?
Yeah, so in the CSS, we set the images to being like 100% with relative width. How does relative width and CLS metric, like how do those play together?
So, so if you're using relative width or heights on CSS, if it's dependent on the viewport, it's not a change, it's not a shift, because the viewport is always the same. But so do you get what I mean? So in this case, if you're doing this, for example, like so, yeah, you have a layout shift. here. But that's not the common use case. I mean, I could see that if I create a time span, then I start doing this. Oh, I can't change the viewport when I'm doing this. I can show you that with this example. So, but if you have something that is moving, then it's a layout shift. Is it bad? Well, with responsive design, you don't have any other option. Every responsive site will have layout shift when you are changing the viewport. That's not the problem. The problem is that when you have layout shift on the page load, when the user is not doing this accordion thing with the window. So I don't think there is a problem with that, actually. Okay?
Sure.
Cool. Well, as I was mentioning, there is always room for improvement. This was actually a very simple sample to actually see in action some parts that I think that are important, such as how to increase your LCP, how to apply some techniques. Just remember to try to not use client-side JavaScript, at least for the first load. If you're using Angular, for example, you have a way to define the component that will go directly to your HTML statically. So then your first page is not just white, and it needs to wait for JavaScript to render the content.
Where would I look to see how you would set it up so it's the server first for the initial load, and then it'd be the client-side rendering for the rest of it, like the individual?
Right. That depends on that's depends on the framework. Next.js, Nuxt.js for Vue.js.
So does Next.js automatically do that?
It will automatically do that. Yeah, you can
okay.
you can set up, you can customize it, but it's automatic. Yeah.
So it's automatic with the server first, client second.
Yeah.
Okay.
That's correct. Yeah. But you are still using React. So every page is a React component. Inside the page, you create React component, you use React components, but the first load, it's actually, I mean, the same Vercel.com is Next.js, and that's the company behind Next.js. If we create, come on, cannot create a new report for some reason. I'm trying to hit there, it's not working. That's weird. Let me remove that one. No? Okay. There. They are typically proud that most of the Next.js websites, they got 99. I'm not sure what we get here. 85, not 99. But that depends on the case because it's a lab experiment. But they're using Next.js, and everything is, when you look at the page source, you see HTML. It's not just client side. Even if it's, I mean, it's not formatted here, so it's difficult to read this. Even it has CSS embedded. Everything is done automatically by Next.js. It embedded that CSS because it thought that that will be faster for this particular example. Okay? Cool. Well, performance APIs. So far, we've seen that how to apply web performance. We create a website, okay? Then you are attending this workshop, you are watching this course, and then you learn to measure things. You apply some techniques that we have been seeing to see if that, I mean, preload, DNS prefetch, 14K, and then you go back, make changes, measure. Okay, that's kind of one thing, which is okay. We do that in the lab. Okay, we iterate over this many times until you go and deploy. When you deploy, that goes to the user. It shouldn't, I mean, web performance optimization shouldn't stop with the deployment. You should also measure real user metrics and do two things. Make decisions on the fly for that user. That's what I mentioned as reactive web performance. So for example, yeah, the latency is too high. Well, let's decrease the amount of data, or let's make only one request and try to bring many things at once. And also, with those measurements, we can go back to apply techniques. We can gather real user metrics and make new decisions that will make changes to the code as well. So that's how your performance process should look like. So it's not just static performance, also dynamic performance on the fly. Okay. the APIs that we will see work client-side. Some data that you get there can be shared with the server automatically or manually, and as every API in the web world is not available, some APIs will not available in every browser. Okay, so sometimes we have polyfills. That's a library that will like simulate, will fill the gap that we have on some browsers. And for that, we can measure timings. What is timing? Remember the waterfall chart? We could recreate the waterfall chart in a JavaScript structure. So all the information you see in the waterfall chart can be accessed by JavaScript, by a JavaScript API. For what? For what you need. You can read type of connection, bandwidth, latency, device memory, and you can create your own custom metrics with these APIs. You can read pain timing, such as first contentful pain, large contentful pain, and CPU intense operations, such as, remember that I mentioned long tasks, these tasks that are taking more than 15 milliseconds. You can get warned every time you're going over that line. So then you can gather real user metrics about, for that user, for that CPU, for that device, we might have a long task problem. So that's known as real user monitoring, or RUM, because we don't know how users are working with our site, just working with our lab. Okay, so it's a good idea to take analytics. Of course, there are a lot of providers out there, companies, where you inject the code and they will do that for you. They have nice dashboards, alerts, but also you can do it yourself. And I will just give you a hint of some ideas that you can use with APIs. There are many APIs. We are not going to cover all the APIs. We can do a full workshop on performance APIs. It's just an idea to get you up and running with the basics. Okay. Let's say that the base of everything that we will mention in this section is under the performance object. Have you ever seen that one? It's a global object available in the context. So if I open any website, it can be mine website. Let's go back to Frontend Museum. We close everything. If I go to the console, we can try the performance object. So that object is actually like the root of most of the performance APIs. For example, there we have a navigation object. On that navigation, we can know which type of navigation do we have. One is actually a normal navigation. So I just type the URL. I can also have a BF cache navigation. So it means the current navigation, the user is going back, or the user went back to our website. Remember BF cache? And also I can see the redirect count. So to get to this navigation, how many redirects were necessary? So over here also there is a performance.now function that will give you the current time, but you say the current time expressed in which unit, which kind of weird, right? If I refresh this and get performance now, it's actually a small number. It's expressed in milliseconds since the 0 of the timeline, since I have started the navigation. And you can use this to measure things on your page to see how much time has passed since. Performance.now will give you, and also it's high precision. Technically, the precision goes to the nanoseconds, but yeah, it's a theory, right? Not the reality. So it's milliseconds, okay, and it's actually much better than doing this. New date, get time. Why? Because this is first the amount of milliseconds since 1st of January 1970. The precision is milliseconds only. And also you are creating an object in memory, new date, looking for memory. So you're actually changing the observation. That's not a good idea. Performance now, you can see it faster. It's actually native and it's accessing like a high precision timer. So on this performance object, we have everything you need for the performance APIs. So we have already seen this. So how to get the current timestamp, we have already seen that. By the way, .time origin will give you the timestamp for the 0, if you need to convert that into a normal date. Also, you can get the redirect count. I already say that, and this is the kind of navigation you have. It's a normal navigation. It's a reload or it's a back forward. And on level 2 means the version 2 of the API, we do have a lot of timestamps. A lot. I don't want to spend too much time with this because it's really boring, but let me show you quickly how that works. We have a navigation starts when the browser starts a navigation. Okay? It's when it's preparing. Then we have a lot of unload events. And by the way, the animation on the lights is weird. Yeah, I think this animation is not going to work. I'm not sure what's going on with the animation. Let's go directly to the last slide, because if not, this will take too much time. It's really long.
Put a preload on those.
Yeah, let me first. I'm not sure what happened with the animation, so I will explain this from scratch, like that. There we go. So actually, what you see there is all the steps of loading a web page, and actually you have a lot of places there where you can get the timestamp, navigation start, fetch start. When the SSL connection started, it's called connect end. When the HTTP request started, that's request start. When the CSS and JavaScript parsing started, that's DOM interactive, and so on. And you can read the timestamp, so you can actually design, if you want, on the screen using Canvas, for example, you can actually design a waterfall chart just by gathering the information from this API. And again, with this you can make some decisions. For example, it's really weird. I don't know what's going on with the animation with my keynote. Let me see. Let's do this for now. Full screen. That's kind of better. There. So if you wanna, for example, calculate time to first byte, you get response start minus fetch start. That's time to first byte. Remember, time to first byte is kind of at the back end time. If you want download time, so the downloading of the HTML, responses end minus response start. You want DOM load time, DOM interactive minus. Parsing and rendering time, and you use that for your own purposes. Does it make sense? That's kind of the idea. And page load time that no one cares anymore, okay, is DOM complete minus fetch start. And now let's go back to the normal play. There is a whole working group at the W3C, it's the performance working group, and they're creating a lot of other specs that some browsers are implementing with time. Typically, Chromium browsers are the one implementing these APIs first, and Safari and Firefox are a little behind. Okay, but there are a lot of APIs. So every API actually works with that performance property that we saw before. So everything is there. And we have, on modern APIs, entries. And that entries are collections of metrics. And we can query entries using filters. I know it sounds weird, but let me show you some samples. For example, you can get navigation entries. Those are the entries we saw before. We can get resource entries. The spec is known as resource timing API. In this case, you can get the DNS resolution, the TCP timings, the download times for every resource, for every PNG, for every CSS, for every JavaScript. Okay? You can say a mark. That's known as user timing. In this case, you can mark your own events in the timeline. So that's, in this case, you say, okay, my tweet is ready. If you're a Twitter, my tweet is ready, or something is rendered. And then you can actually get an observation of when that happened. Okay, so you can create your own custom metrics with user timing API. And if you use user timing API, you can measure, so you can calculate. I have this measure and that one. Well, give me the duration of that process, and I do something with that. Analytics, making a decision on the fly that you want to change something. So to get in the old version to get entries is performance.getEntries by type. That's deprecated. It's still working, but it's deprecated. The properties are name, entry type, start time, and duration. And I know it feels still weird. We will show that in code in a minute. And the new version, instead of getting the entries, we create observers. Why? Because sometimes we don't have the data yet. We need to wait for it. So now we create observers. There are listeners. So we observe for those kind of performance moments. For example, let's see what you see here in action. Performance observer.supported entries. If we go here to Chrome and we talk to the performance observer and we ask for the entry types. So Chrome supports all these types of observers. So for example, I can observe largest contentful paint, which is good. So now you know what that is. It's the most important metric that we saw from Web Vitals. So which means that when the browser, if I create an observer over that entry, then when the browser has said, oh, we had a winner, we know which element is the largest contentful paint, and we know we have the metric. It will execute our observer, and we will receive the data. We will know the LCP in JavaScript. Does it make sense? First input delay is this one. This is CLS. So actually from Chrome, you can actually get the 3 Web Vitals in JavaScript just by creating an observer over the performance option. Let's say, for example, long task is the observer you will use to know when a task is over the budget. What's a task? A JavaScript thread. If you have some JavaScript code that is looping through 1,000 elements and doing something with that, it's taking too much time, well, the observer will receive the information. That script, that line, it has just execute code for 100 milliseconds. It's over the line. And then you can query your server. But not every browser supports the same kind of types. That's not what I want. If I open Safari, and we, let's open Safari here. We inspect here, we go to the console. We only have 5 kinds. We have mark, measure, navigation, paint, and resource. So we don't have Web Vitals. We have paint, that's first paint. First paint is when something appears on the screen. That doesn't mean it's content or it's useful. Okay. So how does this work? We can actually try this directly in our code. You can see it's actually pretty simple. It's not so complicated. For example, in our script, we create a new performance observer. Okay, just that. And we observe different entries. For example, here I can say which entries do I want. For example, I want largest contentful paint. We are talking about this. I want largest contentful paint. And this is an array. So if I want all the Web Vitals, I can also pass the other 2. But for some reason, they don't have the full name. So it's not CLS, content layer shift. It's just layer shift. Who knows? And the other one is also first input and not. The second argument is buffered true or false. Why is that? If you say true, when you start observing events, maybe the event has already happened. Does that make sense? So if you say buffer true, you're asking, hey, if the event already happened, give me a call anyway, immediately. I want to receive that. Buffer false will just give me an execution only from now on, not if the data is already buffered. Does that make sense?
So is it false in Safari?
In this case, no, that's not, I mean, Safari also supports true and false, but Safari will not support these entries, so it will never execute my. I can also add paint. That's the one supported by Safari, for example, and there it's going to execute your observer, and you will receive entries. And for now, I can just do console log, just to see what's going on. Does it make sense? I mean, the code is not really complicated. The thing is understanding that that's a possibility, that that's available. So I'm going to refresh, and now I'm seeing some outputs. I have actually two outputs. One, it seems like at the same time we've got first pane and first contentful pane. Why we've got it at the same time? Probably because they were buffered. I don't know, but maybe. And each entry has the start time. They happen at the same time, first pane and first contentful pane. And then we have the largest contentful pane that if you try again, it takes some more time. This is the load time, the render time. Okay, and even we receive the URL of the image that is actually pointing to the largest contentful pane. And by the way, we can go back to our delay thing just to see this in action. We can even increase the maximum delay so it's not so immediate. So now we get this. In this case, you can see it started at 2.7 seconds, largest contentful pane. So that's the LCP. Okay, does it make sense? How that works? Why do you want the data? It's up to you. Maybe you want to send the data to the server. Maybe you want to make a decision on the fly, like, hey, this is, I mean, loading this app took a lot of time. So from now on, let's load a basic version of the app. Or let's jump into a standard version instead of high definition, whatever. So the API is just giving you the data. It's up to you what you're going to do with that. If I try this on Safari, because it's not supporting the whole API, we should get only the entries that are important for Safari, and that's first paint. First contentful pane, also known as first paint, it happened in almost 5 seconds. We don't have the largest contentful pane yet. We have the first contentful pane. That is probably the logo here. Probably, I don't know. Does it make sense?
How does it know which elements are contentful?
That's defined by each browser, but typically they define content today as text, visible text, or images. For example, if you have a video, typically it's not a candidate for largest or first contentful pane unless you have a poster, because the poster of the video is an image. And in that case, the poster is content, but not the video element by itself, because the video element is like black by default. So it's not taking in consideration for LCP.
Is it picking largest from geometry?
Geometry, yeah, that's correct. And by the way, it's while the page is being rendered, who is the LCP might change. So actually the browser first decides, okay, the current candidate is this one. Then another thing appears, no, now the candidate is this one. Then when the page finishes loading, it says, okay, the last candidate is actually the largest. Does it make sense? So with this, you can make real user metrics, right? That's kind of the idea with performance observers. Well, here I have more examples of the same thing, so we don't need to go over the slides. Device memory. This is available on some browsers. again, why is this important? Just for the context, you have more context. It will give us the number expressed in GB bytes. Okay? And it's giving just 1, 2, 4, or 8. That's all. For example, my Mac has 64, but it's not going to give me 64 gigabytes of RAM. It's navigator.device memory. Pretty simple. So we go to navigator, device memory, 8. And let me show you that that's false. It's 64. But anyway, the idea is to reduce fingerprinting. So whoever wrote that part of the spec believed that having 8, 16, 34, 64 from a web perspective is just the same. You don't need to know more details. I didn't write the spec. Don't look at me like that. That's what the spec says. So as of today, it will give you up to 8. I mean, I think that for WebGL or Web GPU apps, games, yeah, that might be important. But anyway, in this case, the idea is to actually know when you are in a low-end device, like an Android cheap phone. And if that's the case, you want to reduce as much as possible code execution client side. Okay, make sense? That's device. Save data flow. As I mentioned before, it's navigator.connection.saveData. And for example, on Android, on Chrome on Android, that's how it looks like. So you enable that in settings. And if you enable that, then in JavaScript or through HTTP client hints, you will get in your server the flag. It's up to you if you want to do something or not about that. Okay, that's save data. So just as a summary of this part of APIs, we can use all the APIs that I mentioned, and there are more. I'm just giving you like a quick rough idea to apply these reactive web performance techniques, okay, to serve better responsive images. To know, okay, the current device has a device pixel ratio. That's the resolution of 4. So it's 4 times the resolution of a classic standard display. Well, based on that, you may want to provide an image that is 4 times by 4 times bigger, so 16 times bigger, unless you realize that the memory is not good enough or the latency is not good enough. So it's not just about one data, it's the mix of information that will let you have better conclusions about this, okay? And for that, we use client hints that we have already seen. So moving to, we are finishing. This is the last part. Where is it? We have already seen the frames. Go here. So for those of you that are using set timeout and set interval, there is a much better way that has been for a while now, but it's still not the way that most developers are using. It's request animation frame. It's part of the HTML5 today, and let us execute code on the next frame before painting the frame. Remember that we saw that diagram with what's going on there? And it's guaranteed to be executed on the next frame, because do you know what happened with set timeout? So set timeout or set interval. So if I do set interval and execute some code, okay, I do something here like hello, hello, and then I say 100. What do you think that this code is going to do?
Console log hello 10 times a second.
Console log 10 times per second. Right. Is it guaranteed?
No, it'll end up based on where it is in like the call queue. That can
Yeah, in fact, it's not guaranteed at all. In fact, if you use, instead of set interval, set timeout, and let's say you have a very important task that you need to do in 1 second, you are confident that that will work, but not really. This is how it works. So when we have that process of painting, things that we have been seeing here, so set timeout are actually being executed within idle callback time between one frame and the other frame. The problem is that what happens if there is no idle callback time? You have some code here in your input events, you have an on-click, you have something that is taking a lot of time. So there is no idle time. No, the browser says, no, I'm sorry, I need to make the other frame. I need to make the other frame. I need to make the other frame. And maybe it doesn't have enough time to execute your timer. So actually, every time you are saying set timeout or set interval, you are actually, it's not a real timer. It's not an alarm that will wake up that code in 1 second. It's just setting that function in some kind of a queue, in a table of code to execute in the future. And the 1000 is not a timer, it's not an alarm, it's actually an expiration date. So when the browser is doing nothing, it says, okay, let's go and see if we have something pending. And it goes over the list and see if it's expired or not. If it's expired, it will execute it. But maybe it has expired 10 seconds ago. So it's going to execute that later.
Would you be able to kind of get around that by like using async kind of setup?
They're talking about the async keyword? Or
Yeah, kind of.
what do you mean by
I'm
async?
not like super like in depth or knowledgeable about it, but like would you be able to have an asynchronous like sort of async keyword like you said?
The async keyword is not going to make any difference here. So because the only thing that it's doing is a sure syntax to promises, and promises by default are not actually like a different thread, something like that. So the problem is that we think that set timeout or set interval are alarms, are crons, and that's not the case. It's just setting code to be executed in the future, and it has an expiration. So I want this to be executed after 1 second. When? When you have time. After 1 second, but when you have time. And of course, that's bad for a lot of situations. So that's why it's a better idea. It's a better idea to use request animation frame because it's guaranteed to be executed at that moment on every frame. But your code should be short, right? Why? Because if it's too long, you will push the whole frame, and then we will have a frame drop in the animation. So that's why we should keep that code small, under 10 milliseconds of execution. Small in execution, not in size. It's much better than timers, okay? You just request an animation frame and do some code. That's all. And it's guaranteed that it's going to be executed on the next frame. Sometimes you need to do something in that diagram, but it's not really important. So if it's enough time, you want to execute that. But if not, I'm okay. Okay, I can wait. For that, we can use that idle time if it's there. It's called idle callback. Actually, the spec is known as request background task. And in that case, you will use that time that can be long or short. You can try to use that one. Okay. For that, you use then request idle callback, and you pass a function. Make sense? It's just that. Another way that you have to make things more performant. Something relatively new on the web is input pending. If you look at that diagram, it has one specific blue color there. I'm not sure if you recognize that blue. When I tell you why, you will recognize it. That's Facebook's blue, because that API was proposed by Facebook, and that's from the original documentation that was proposed by Facebook, and now it's on Chrome. That API is input pending. Will give you the idea of if there is anything in the queue to pending that needs to be processed. So let's say you have a long running JavaScript you need to execute. Okay, then you end that process, and at that moment the browser has time to check if the user clicked or scrolled, input events. But that can lead to a problem, because for a lot of milliseconds or even seconds, the user didn't see any change. Well, instead of doing that, you can split your JavaScript, and every once in a while, you can check, is there any input pending to be processed? And if the answer is yes, you will release the thread, and you will continue later. So you register another request animation frame. Does that make sense? So you leave, it's just a flag from the browser to the developer saying, I have pending things, so if you can, leave me some space. Does it make sense? That is input pending. So then you can make like small things, small spaces asking. Does it make sense? And because you're asking, you are not yielding between the browser and your code. You're just asking, if there is anything pending, I will give you time. If not, I don't need to give you time. That's much faster. Okay? This is how it works in terms of code. And it's not a big deal. We don't need to go really too deeply. But actually, it's navigator.scheduling.is input pending. It's just that. Request idle callback is the one that I mentioned before. It's known as cooperative scheduling of background tasks. And when I say background task, a lot of people say, oh, that's good, but that's not what you're thinking. Okay, so it's just to execute low priority code before each frame, if there is enough time. Remember, the idea here is to keep the frame rate consistent. So, and it says an argument where we can query how much time is left. So it's like, it says, there is only 10 milliseconds. And you say, oh, no, I can't do what I need. So, okay, let's try the next one. Okay, make sense? So it's request idle callback. You receive that argument, and then you check how much time is left. That's all. So instead of set timeout, you use this one. It's request idle callback. What if there is no idle time? The browser will retry on each frame, and you can specify a timeout. It's like, you know what? I can wait. I'm patient, but after 3 seconds, okay, give me some time, even if it's not idle time. Okay, make sense? Just the timeout property. So you can see the APIs are pretty simple. You just need to understand when to use them and how you need them. That's all. Efficient script yielding. In this case, it's a way to yield control to the browser before running our code. It's the new version of setTimeout 0. I'm not sure if you have seen that before. So setTimeout, I've used that in a lot of web apps. Like a decade ago, doing apps for smart TVs and smartphones. The idea is that you say, you know what, I need to execute this code. Okay, I need. But first, browser, I need go and do your stuff and then go back to me. Why do you want to do that? When you're doing Vanilla.js and you're working with the DOM and you make a change in the DOM, until you release the thread, that change is not actually on the screen. Does that make sense? So maybe you change the DOM and you want the browser to update the DOM immediately. But you still need to continue executing code. So then you yield control to the browser and then you go back. It's called set immediate. It's not a big deal, but set immediate and you pass the code. And so then the browser will do its stuff. And after that, immediately, it will execute the function that you pass as an argument. Does it make sense? Okay. Any question on APIs? There are much more APIs, right? Just like a summary, quick summary. Yeah.
In the web, there exists a distinction between websites and web apps. Are there any differences I should consider while thinking about performance? For example, is it okay to sacrifice some website metrics to gain others?
Well, I think that you always need to sacrifice something. I'm not sure if it's between websites and web apps. That actually, it's a distinction that is not completely clear, unless we are talking about PWAs, progressive web apps, where there is a more clear definition because you need to follow some PWA criteria to be a PWA. But between a website and a web app, I mean, there are some situations when you feel it's clear, okay, the New York Times is a website and TikTok is a web app, it feels like, or your home banking is a web app, it feels like more clear. But in the middle, you have a lot of situations. So performance is the same for both, okay? Because the website has some goals. Maybe the goals are page views and seeing ads, or reading, people accessing and reading your content. And web apps needs more interaction, more logins, more, I don't know. It depends on the case. So I think that the answer is more dependent on what conversion means for your project, more than the type of project. Okay? So you always need more conversion. Just to give you an example, Firefox, the Firefox website, improved performance for more conversion. Okay, what's the conversion for them? For them, it was getting more downloads. So they increased performance on the website and they got more downloads. I remember one example that they showed at one conference, web performance. It was a long time ago when it was the Obama campaign for US president. They increased the performance of the website and they got more money donated from people just by applying more performance. So every website has a conversion. You just need to find what's your conversion and work for that, because remember, we are doing this for that. That's our goal, not because we are geeky nerds of web performance and we like to see the milliseconds being drained over the wire. That's not the case. We are doing this because it improves the business that we have on the web. We or our company or our clients. Okay? Make sense? Any question on APIs? No? So, today, we've covered what's the problem, why web performance is important, the metrics. We've seen a couple of metrics, not all metrics, but the most important metrics, such as speed index, time to first byte, the core web vitals, CLS, first input delay, that it's kind of being deprecated, and probably the most important one, the one that we want to focus initially for the initial page load, that is the largest contentful paint, or LCP. We've seen briefly some tools, but now you know the tools, it's time for you to get deeper with those tools. Lighthouse, DevTools with a network layer. We've seen Page Speed Insights, that is taking information from the Chrome UX report on your real users. We've seen Web Page Test. It's a pretty cool option, a pretty cool tool that you will use a lot as a web performance engineer. We've covered briefly charts and diagrams, the most important one being the waterfall chart. The bars that we have there, the lines, the milestones, over there the film strip view, how you can see in action the screenshots of your web while it's loading. We understand the browsers, so how browsing works. So when you type a URL, what's going on there? What are the steps? And why then we need to do some things to improve performance. We've covered basic optimizations, then a lot of other more hacky things to apply and like get really move further the optimizations that you can get. And finally, a quick hint on performance APIs available in the client. Just remember always, why are we doing this? I think this is important. Don't apply all the techniques just because you read an article, or you were here watching this video, or you were here doing this course. That's it's not important. What is important is to get better metrics, because that will lead into more conversions. Because just remember that performance should be top priority for a lot of websites, because it impacts directly the business. There are much more tricks, okay, to push the limits. So it's actually a huge discipline within web development or web engineering. But I think it's a worthwhile effort to actually do that stuff if you remember what's the goal and why we're doing this.
So it seems like a lot of this stuff is just like taking a while to get adapted as like an industry like standard as well. Do you see that like a lot of that changing in the next 5 years, just like being automatically sort of configured into it?
Well, there are many of the things that we've covered that are being automatically applied when you are using some tools, some proxies, when you are adding a front on top of your website. Again, talking about Cloudflare, they're not paying me so to mention them. But anyway, I don't think, unless machine learning and ChatGPT replaces us in the future, but I don't think that there is still that it will replace human work, any automatic tool, because there are a lot of things that, I mean, we mentioned that before. You can get a really good score at Lighthouse and be pretty bad in the real performance, or the other way around. So while tools can help, we still need to make manual decisions, and for that you need to understand web performance. And while techniques might change with time, the basics are still the same. It's understanding how HTTP works, understand how the network layer works, what the browser is doing. When you understand how that works, then you understand when you have a problem, why is the problem there, and how to solve that. We need to understand how painful requests are by default. So from now on, you should try to be more careful about adding more assets, because our budget is limited. We don't have unlimited budget. It's a small budget, so we need to be very careful about that budget. And we are spending the budget sometimes without even knowing that that's a problem. Okay, so feel the pain, feel with the browser how painful it is, each HTTP request, and make it work. So if you are going to make a request, it should be important. Okay, that's kind of the deal here. Okay, because performance is important. Just if you're here at frontendmasters.com, it's a really, really fast app website. You can try it. Probably you know that. Well, it's Manila.js, and that's the reason. And because you take performance as important, and when you do that, you think about that, and every step you make, you think, will it impact performance negatively or not? And then you make that decision. Okay, going back to the idea, the original idea, are you feeling bad enough about what you have been doing and how and why it was slow? Okay? But anyway, I hope that you learned at least a couple of new tricks that you didn't know to improve web performance. Having said that, that's all I have today for you on web performance. That's much more. You have the ebook. You have a copy of the ebook also if you want to read more on web performance, and keep engaged with the community because it's a big community. Questions? Have a question?
I'm not sure if you mentioned, but Todd Gardner has a web performance course. We also have JavaScript performance, specifically with Steve Kinney. And then what else am I missing? It's performance related.
Will Sutton says, or no, something in the expert learning path. I'm forgetting about.
You can search performance in the
Yeah.
in the search box, and you will find all the content. Also, probably smaller parts of other workshops as well that are talking about performance and within other concepts. Also, in terms of service workers, you had the one from Kyle Simpson. Also, the storage one that I did covers cache storage and service worker. That is important for improving web performance.
Yeah, you have the PWA course.
The PWA course also. Do you have any final question, comment,
Oh,
opinion?
yeah, and the other one I was looking at was React performance.
React performance.
If you're looking for that specifically.
Or maybe learn Next.js or a server side.
We also have that, yeah.
You have any question?
Any other final questions?
You feel tired. And I was the one speaking, doing all that stuff.
Ilya in chat says, was a great workshop. Kudos to all of you, let the power of SVG be with you.
Okay, that's for a T-shirt. Right? That's-
We do use SVG for like our website logo. And
yeah, it's for the
various
logo, some
icons.
icons. That's all.
I have a question. You know, I think you talked a lot about how like it's easy to make performance a priority when it comes top down.
Yeah.
The CEO's friend or something complains. But going bottom up, like as a individual developer, is there something that you have found has been an effective way to convince people?
I
take
think the most
performance
convincing way is to create a video of the loading process from web page test, where you can actually see, when you say 12 seconds, they say, oh, that's fast. When you see 12 seconds of white with the timer, you feel those 12 seconds. And I think that's good enough. And the other thing is probably play golf and try to get into the CEO
Become an executive
game.
first,
Yeah, but
Or work for a company where the CEO is a developer and cares about it.
well, yeah, that's another. But in my experience, if you don't have the whole company on web performance, if it's difficult because sometimes you need to make concessions. I mean, the company, some other parts of the company need to make some concessions to make that work, because and if there is no enough believe in. If they don't believe, the company is not believing in you, it's like, oh, again, you are the geeky guy with the timer. And they don't understand that that's not the case. Or maybe that's the case as well. But we are doing this because it's better for the whole company. And it should be top priority. And if infrastructure needs to make a change in how they're doing things, it has a cost. Okay, it's an investment because you will have a return. There is a ROI there, return of investment. Yeah, someone needs to convince first, at least the second line, at least the CTO, so the CTO can fight for that in the rest of the company. That's the case. But yeah, it's not simple. I know that when you are just a developer, you are the geeky person, and no one actually believes that that's true. I mean, Google has a lot of case studies on web performance on their website, where big companies already they are showing their information, where they say, oh, we increase performance. I'm talking about e-commerce sites, sites from travel sites, enterprise solutions, and well, you can gather information, create a report, and say, hey, we can do the stuff. And also, the experiment that I mentioned, similar to the experiment that Amazon did, is also another good idea. If you get approval for that, you create an experiment of adding milliseconds to every request or to the page load for groups on the same day at the same time, and see how the conversion rate changes. And then with that, you will prove that on your website, for your website, like the better performance, the better conversion. So that means that now we need to go down from where we are. If we go down, we will increase that.
Make money.
Yeah, we will make more money.
Faster, yeah.
So would you say most companies are just looking to get the product working, essentially, then? Because I haven't worked in a real position.
Yeah, well, companies are complicated, and yeah, you need to fight for a lot of stuff, and sometimes, yeah, that's why, I mean, as a user, you probably see a lot of things, how this company is doing this thing as it is. Well, it's a company, that's why. The larger the company, the more complicated it gets to achieve the goals.
Yeah, and I'd say the easiest thing to do when you're building a feature is npm install something, but I'll make a pitch for Max's. You don't need that framework course or vanilla JavaScript course that will be out soon. Yeah, think about, instead of npm installing the feature to hit the deadline, maybe stop for a second and think, how could I do this with native web platform features? How can I do it with a little less, or just, a simpler way before reaching for something big? Because that's what ends up with these massive bundle sizes and slow websites. If you just took a little bit of time to think through, how can I make this simpler? Even if you're using React, like make something just with React instead of npm install a big thing and then use a small component from a big library.
Yeah, but it's also true that sometimes if you're just a developer, you just receive the rule that we have to use React. They say, well, you need to fight internally, but yeah.
Awesome. Thanks, Bex.
Okay, thank you.